In 4.4, we're going to be solving special systems of linear equations. So we're going to have two special situations where our system of equations works out to be kind of funny. So we'll have one situation where there are no solutions and one situation where we have infinitely many solutions. So our learning goal today is I will solve systems of linear equations having no solution or infinitely many solutions. So we have these two special cases, and I'm going to show you the reason why we have those special cases first. If you think about when we were solving these systems, remember one way that we can think about them is as graphs. So if I have a graph of one equation, and it looks like this, and then I graph the other equation, oops, and it looks like this, here I have two parallel lines. And those parallel lines are never going to cross because that's the definition of parallel. So if when I graph my linear equations, I get two parallel lines, this is going to be a no solution situation because these lines can obviously never intersect, so there can't be a common point between the two lines. Our other situation that can pop up is maybe I graph my line, the first line, and then I graph my second line, and I see that my second line, you can't really tell because it's black, but my second line is right on top of my first line, which means every single point that's on the black line is also on the red line. This would be a situation when we have infinitely many solutions. Basically, any point that's a solution for one line is a solution for the other as well. So now you know what they look like. And just as a reminder, typically our non-special cases look like this, where we have our axes, oops, and then one line, another line, and there's our solution. So this is what our situation might look like when we have one solution. So intersecting lines always result in one solution. Parallel lines result in no solutions, and they're called like coincidental, or where the lines coincide. Basically, two lines that are the same gives us infinitely many solutions. So these are our three cases with solving systems of equations. We've already done these. Remember, we used elimination, graphing, or substitution to find that intersection point. Today, we're looking at these two cases. Our first example gives us the system y equals negative 2x plus 5 and y equals negative 2x plus 1. I can graph this, I can solve it using substitution, or I can solve it using elimination. I am going to use substitution. These are both y equals, which means I can set these two equations equal to each other. So y equals 2x plus 5 equals 2x plus 1. To solve this, let's add 2x to each side. Negative 2x plus 2x is 5. Negative 2x plus 2x is 0, so I'm left with 5. Negative 2x plus 2x is 0, so I'm left with 1. 5 can never equal 1, so this is no solution. If I had graphed this, I would graph a line with a slope of negative 2 and a y-intercept of 5. This line has a slope of negative 2 and a y-intercept of 1. So they have the same slope, but different intercepts. That tells you that these are parallel lines. So again, that would tell me no solution. These two lines never intersect, which means I can't substitute any point for x and y and have it work for both equations. So the thing that you're looking for no solution is when our lines are simplified, we have the same slope if they're written in slope-intercept form, but different intercepts. Okay, our second example, we're going to have two equations. How about 4x plus 8y equals 36 and 12x plus 24y equals 108. So here I have two equations. When I look at them, the coefficients right now are all totally different. But I'm actually going to use elimination in this case. Because what I can do is I can take this top equation. If I multiply 4 by 3, I get 12. So then I'll be able to eliminate. So let's multiply that top equation by 3. And I get 3 times 4 is 12x, which is what I wanted. 3 times 8 is 24y. 3 times 36 is 90 plus 18, which is 108. When I write my second equation down underneath, you should notice these two equations are exactly the same. I have the same coefficient for x, I have the same coefficient for y, and they're equal to the same number. So no matter what I do to solve this, if I subtract, I'm going to get 0 plus 0 equals 0. Or 0 equals 0. So this situation, these are the exact same line. If they're the exact same line, then that means that every xy pair that's a solution of my first line is a solution of my second line. So I could say infinitely many solutions. So I spelled that wrong. So any point on the line, and let's go back to the simplified version, any point on the line 4x plus 8y equals 36, any point that works for that is going to work for the second equation that's given as well. So in summary, no solution is going to happen when we have parallel lines. The way that you're going to be able to tell your lines are parallel is either they have the same slope if they're in slope-intercept form, or if x and y have the same coefficients, but they're equal to different things. So 2x plus 3y equals 8, and 2x plus 3y equals 5. This is going to be a situation where you have no solution. Your x's have the same coefficients, your y's have the same coefficients, but we're equal to a different number. You could also have a situation like 3x plus y equals 10, 6x plus 2y equals 8. This is going to be another no solution situation, and I can tell because if I take my first equation and multiply it by 2, I get 6x plus 2y, but then I get equals 20. And this guy is 6x plus 2y equals 8. So I don't even actually have to go through and solve in order to tell that I have no solution. And then remember that our infinitely many solutions is where that's going to be where I wind up with the exact same equation. So the same coefficients equal to the same thing. So if I use my 2x plus 3y example from above, 2x plus 3y equals 8, 2x plus 3y equals 8. Now that one is super obvious. You're probably not even going to see one that looks like that. But if we use our 3x plus y equals 10, 6x plus 2y equals 20. This one's a tiny bit less obvious because we have to do that multiplication first. where we multiply the top equation by 2. 6x plus 2y equals 20, and now you can see really obviously that I have the same equations there. So those are our two special situations. If your coefficients are different or not a multiple of each other, then you don't have to worry about it. Then you know you're going to have one solution. So those are our special cases, and you can go ahead and start working on your homework.